This is an absolute extrema problem. We need to pay attention to two things that could easily trip us up. First, there's a closed interval given to us. We need to make sure our absolute extreme value falls inside that interval. Secondly, we need to test the endpoints and compare them to whatever we find inside the interval, okay? Any critical points we find inside. Thirdly, the question is asking us what the maximum value of f is. So it's not enough to just find where it is. Once you found the x coordinate, plug that back into f to get the value of f. Now, let's do it. Look at the first derivative. We see it right here, 3x squared minus 12x minus 15. We're going to set that equal to 0. That's where we'll find critical points. We should also remember that critical points can occur where the first derivative is undefined. That would mean if you had a denominator in your expression, you could find where the denominator is also going to 0. That would be an undefined point in your first derivative. Here we don't have any of that. It's simply 5 and -1. Now, -1 is outside the interval. So we cannot consider that, even though if we looked at the sign test, that would be a maximum. But that's not eligible. We're not eligible. That's not eligible to us. So we're going to look from 0 to 6, and we see that 5, based on the sign test, is a minimum. So that's not our answer. We test the endpoints now, 0 and 6, and we see that, in fact, at 0, we have the highest value of f, and it happens to also equal 0. F of 6, by the way, is -90. Now, I want to make the point that even if -1 were inside the interval, let's say that your interval went from -2 to 6, I would still want to test the endpoints because my -1 maximum may not be higher than the endpoints. Because as you can see, at 6, I'm rising. Well, starting from 5, rather, we're rising up. We are increasing. So until you actually test the function, you don't know if 6 ends up higher than the relative max at -1. Please pay attention to your endpoints. And the last reminder is that you could also use a second derivative test to know if critical points are maximums or minimums.